Hello, this is Certified Pre-Owned, Abusing Active Directory Certificate Services. My name is Will Schroeder. I am Harmjoy on Twitter.
I'm Lee Christensen, Tifkin on Twitter.
And we are both technical architects at Spectre Ops. So what we're going to cover today, it's all about Active Directory Certificate Services. There's a lot of information here that we're going to try to condense as best we can. So we're going to hit some necessary background on what Active Directory Certificate Services is, templates, how these things interact, some interesting settings for that, some account persistence from the user and machine context, so ways to steal people's credentials, as well as ways to persist on systems for long periods of time, kind of some cool LSASS-less credential theft. Then we're going to cover domain escalation, so 8 different misconfiguration scenarios that can result in domain unelevated users elevating in a domain to domain administrator or equivalent rights. Then we're going to finish off with some persistence with golden certificates, so forging certificates that can't be revoked. So Active Directory Certificate Services. ADCS is a server role that functions as Microsoft's public key infrastructure implementation. So PKI, why would someone do this internally? Well, it's used by organizations for things like smart cards, for internal SSL certificates, code signing, a large number of different things. There's also different tie-ins with like Azure and things like that as well. A CA doesn't have to be a server separate from a DC. It can be, but it doesn't have to be. And this is a really complex and not properly understood system. So we started diving in about 5 months ago, and this, the results of all that research is this presentation. So at a high level, clients will send what's known as a certificate signing request, a CSR, to an enterprise certificate authority, a CA, which signs the issued certificates using the private key associated with the CA cert. We'll walk through this graphically as well. So an enterprise certificate authority generates a self-signed certificate that's then included into the NT-Auth certificates object in the domain. This is what's displayed here through a tool called Certify, which we'll cover, as we're releasing this with the presentation as well. So these are certificates that enable authentication for Active Directory, essentially. And it doesn't have to just be the root CA. We see here the DCCA there at the bottom, that is the root CA. At the top, the CACA, that is a subordinate certificate authority. So both of these, the private key associated with these certificates, can be used to sign certificates that can then allow authentication in the domain. So this object, this NT-Auth certificates, abbreviated to NT-Auth often, is the root of domain-based certificate authentication.
So certificate enrollment. So how do you actually go about obtaining a certificate with ADCS? Well, underneath, the very first thing that a client needs to do is generate their own public/private key pair. And then once they have that, they will generate a CSR, or a certificate signing request. And what this is it's basically just like a message, and inside that message, it contains some information about the certificate that they want to request. So this includes like what it's used for. So for example, like code signing or TLS or whatever. It includes info about the subject of or whoever is requesting the certificate, and also it contains a field containing the template, and we'll talk a little bit about what that is in a sec. So this message gets sent to the CA. The CA looks at the certificate, the CSR, the certificate signing request, and it looks at that template that's specified. The template is basically a blueprint of settings that the certificate is going to have once it's issued. And assuming that what the CA is going to do is it's going to take a look at the CSR, it's going to compare it to what's in the template, assuming everything is allowed. So is this user actually allowed to obtain a certificate for what they're asking? The CA will then sign a certificate using its private key and then return it back to the client. And so then the client's going to take that certificate it has, and it could put it in the Windows certificate store. That's where most certificates will be found. But at that point, the client can do whatever it would like with the certificate. So a little bit more about certificate templates. So certificate templates are AD objects, and what they do is they're blueprints of settings for a certificate. So there's a bunch of different settings that certificates can have, such as like the lifetime, what it's used for, who's actually allowed to request those certificates. So there's a bunch of different kinds of settings. Here on the right is one specific setting that you want to be aware of, which is called application policies, otherwise known as enhanced key usages. But this basically is defining what the certificate can be used for. So here you can see a few different EKUs, so the enhanced key usages. Down at the bottom, there's one for client authentication, one for code signing, one for smart card logon. So this is what the cert can actually be used for underneath. And something important there is like this is certain EKUs permit domain authentication. So here you can see client authentication and smart card logon. Either one of those EKUs, if present in a certificate, means that that certificate can then be used to authenticate to Active Directory. So when that authentication takes place, something that's useful to know about is subject alternative names. So when you auth with a certificate to AD, basically what a SAN, a subject alternative name, allows a cert to do is bind a different identity to it. And so this is a generic, SANs are generically a different way that you can bind multiple identities to one cert. This is commonly used in things like TLS certificates, where you may have a single web server that's serving content for several different domains. So you'll have one cert, but in the SAN, there's going to be an entry for each one of those domains. But in the case of domain authentication, the SAN is used to specify the who you are going to log on as with the certificate, or who the certificate is valid for.
So that can become dangerous.
Yes, that can be very dangerous because if I, an attacker, can manipulate that field or specify that field, then I potentially could specify I want to be a DA or something. So we'll talk a little bit more about that later. But ultimately, the important thing here is whatever's in the SAN ultimately ends up getting mapped to a user account in AD during authentication. That's kind of what you're seeing here. Is you can see a subject down in the bottom left, Harmjoy, but in the subject alternative name, there is a separate user called administrator. And so ultimately, AD is going to log on as the administrator user when authentication occurs. Before doing this research, my understanding of certificates was in regard to Active Directory, is they were mostly dealt with smart cards. This is not true. Certificates are used all over the place, and particularly in the context of domain authentication, you do not need a smart card in order to authenticate to AD with a certificate. In particular, so Rubius and Kikyo have implementations to authenticate to AD using a cert. Rubius obtained this capability. What was it?
It was last year from CCOB or Ethical Chaos on Twitter. Did an awesome pull request to Rubius to allow PK init usage, so the ability to authenticate to Active Directory and get a ticket granting ticket using a certificate. So this was the missing piece for us. We didn't know it at the time, but this really kind of enabled a lot of the offensive applications that we're going to talk about. Because if it wasn't for this, we would have to try to use a virtual smart card or do some stuff on host or pivot things in, which some people have done some research in the past on. It just gets much more difficult. Being able to use this, a C# compact toolkit over like a command and control channel with the ability to do this really flexible PKNet authentication with certificates is awesome. And it can become really, really powerful, which we'll show.
Yep. And so that's what you're seeing down at the bottom. This is Rubius, this Kerberos attack tool. It's authenticating to Active Directory using a certificate file. So in this case, the certificate is that .pfx file. And here you can see we're requesting a Kerberos TGT with Rubius, and down at the bottom, it's outputting it. So this Rubius will authenticate using Kerberos. In addition to Kerberos, you can also authenticate with a certificate using S-channel, which is the SSP that backs like TLS. And so the most commonly enabled protocol that supports TLS client authentication, I'd say, is LDAP-S. And so, for example, you can authenticate to Active Directory over the LDAP protocol using a certificate.
So that's all the background. Now we're all experts in ADCS. That was 5 months of understanding, trying to cram into 10 minutes. Now we're going to get into some of the attacks. We are just focusing on offense here in this presentation. We'll talk about some more material at the end from the defensive standpoint or where you can find it. But the first thing we're going to talk about is account persistence. So long-term credential theft without touching LSAS for both users and computers. So we kind of split this into passive and active theft and then user and computer theft. And there's different applications for each. So for passive certificate theft, the way we view this is if there is an ADCS environment already installed and hooked up to Active Directory, it's often used. There's a reason that it was put there. So very, very often we see that users or machines will have client authentication certificates or some other types of certificates on a host. So if these certificates, they have a private key associated with them. If the private key is not protected by hardware, so if it is not protected specifically by like a TPM, HSM in some cases, or smart card, it's more common. If it's not protected by hardware, then it's protected using DPAPI, the Data Protection Application API. So it's stored on the host in a way that you can recover it if you're executing code in that user or machine's context. So Mimikatz and SharpDPAPI can steal these certificates and private keys. There's also, like, Cert Stealer from the Wover that came out recently. This is a screenshot of using SharpDPAPI to recover the private key for a user context. I'm not going to get into all the different ways you can abuse stuff with DPAPI. There's lots of documentation on SharpDPAPI and the README as well as with the Mimikatz stuff. But just showing that if the cert is already on the host, there are ways that you can steal it and then reuse it for, say, auth.
Yeah. An advantage to this too is it can also export unexportable certificates. Yep. So certificates can be marked as non-exportable, yep, and this will allow you to get, yep, those certificates as well.
Now, the more interesting thing to us is active certificate theft. So users or machines can enroll in any template that they have enroll permissions for. Again, we're glossing over a chunk of stuff here, but suffice to say, there's a couple of default templates, specifically the user and machine templates, that allow domain users and domain computers to enroll, respectively. And these templates allow for domain authentication. They have the client authentication EKU in them. So if I'm in a user's context, I can just actively enroll in this template and get a cert for it. Because we want that template that has AD auth, because to abuse it for a user, we can use like Rubius to get a user's TGT and also get their NTLM, their plaintext NTLM. We'll talk about that in a few slides. But from a computer context, it lets us compromise a computer through resource-based constrained delegation or just S4U2 self.
Which basically means that we now have persistent access, yep, to this computer. We can auth as that computer account, yep, with a certificate. So we can enroll in these through either DCOM using a tool called Certify, which we'll talk about that we're releasing with this talk, through RPC, as well as the ADCS web enrollment endpoints, which we're going to talk about in a few slides in one of the next sections. So this is what Certify looks like. There's a lot of abuses for a lot of things that Certify can use to find and abuse these misconfigurations. It's a C# toolkit that, again, we're releasing with this talk. Here in this case, we're requesting a certificate for the user template using our current context, and we're specifying the certificate authority. So after this, we now have a PEM blob that we can transpose or transform to a PFX that can then be used with Rubius. So running this in a non-elevated user context lets us steal this user's credentials essentially, or it lets us authenticate as that user for a long period of time. And we'll talk about timelines here in a second. So we think this is pretty cool from an offensive tradecraft standpoint, because some of the advantages are it doesn't touch LSAS. So everyone's worried about like different ways to like mini dump or rip memory out of LSAS because people want credentials in order to re-authenticate as somebody. If we're talking about the end goal of being able to authenticate as that person on that machine in the domain, this gives us an alternative that doesn't touch LSAS at all. And it doesn't even need elevation for user context. We do have to be elevated for a machine context, because you can imagine if you could just request a machine cert non-elevated, that would be an instant prevesc, and that would have to be patched. So you do have to be elevated to request a computer cert, but again, you don't have to touch LSAS, and that's an alternative machine persistence method.
There's also very few detection methods because this is a new technique. We think there's some stuff kind of written about it a little bit, but we're hoping to popularize it to a degree and get more defenses in place. We talk about a large chunk of detection and prevention methods in a white paper that we'll talk about at the end of the talk. So it's Lee is a fan of saying like everything is stealthy until somebody is looking for it. So right now nobody's looking for this, so it's probably going to get by things much better, especially versus like ripping stuff out of LSAS. But it's definitely detectable. If people write, you collect the correct telemetry and actually write detections for it. But also, it's separate credential material from passwords. It works even if an account changes its password, because the cert's still valid, and has a long lifetime. So by default, the user and machine templates issue certificates valid for 1 year, but this can actually be, increased. Like we've seen certificates for 3 or 4 years or 5 years. So if someone had actively maliciously enrolled for a user or system in one of those templates, they could come back years later and still authenticate.
And this is crucial for incident responders to understand too, is because I've seen certificate tradecraft or certificate ADCS processes absent from most incident response like playbooks. And so if an account gets compromised or a computer gets compromised for 5 minutes, an attacker could obtain certificates that could maybe work for up to a year, even across machine wipes or if the account's password is reset. So this is very awesome from an attacker perspective.
All right. Now, domain escalation.
So we talked a little bit about templates. Remember, templates are those blueprints of settings that define, when you like characteristics of the certificates. And when there's a set of settings on these templates that may enable privilege escalation in a domain. But some general requirements in order to use these are first, a low privileged user has to be able to request a certificate. So a low privileged user has to be able has to have enrollment rights in order to obtain a certificate or request a certificate in the first place. How this is defined is in order to enroll in a certificate template, the template needs to grant the user access, and that access is defined on the certificate template AD object. And so there's a security descriptor on that object that grants enrollment rights. In addition, another setting on certificate templates is a setting called manager approval. And this is a setting, it's a protection that can be enabled that basically says, I can request a certificate, but before the CA is going to issue it to me, another person needs to come in and review it and then approve it. And so in order for instant domain escalation to occur, we do not want that to be enabled. In addition, there's another thing that we don't really have a lot of time to go into, but it has to do with enrollment agents, and it's called authorized signatures, and basically
it's another protection.
Yeah, another protection.
It's another requirement.
So I'd say the most widely known, or the misconfiguration that we've seen most widely is one where an attacker can specify an arbitrary SAN in the certificate. So remember, the SAN specifies who the certificate is for in Active Directory. So when you log on, AD will look at the SAN. So if an attacker, can specify the SAN, I can become basically anybody. The certificate also needs to enable domain authentication. So it needs an EKU for client authentication, smart card authentication, sub-CA, any purpose, any of those. In addition, when you request that, then the CA needs to actually sign and issue a certificate back, processing the attacker's supplied SAN. So there's certain settings that need to be enabled in order for the CA to process the user supplied SAN. And if all of those conditions are met, then an attacker can become any account in the domain. And so that's what you're kind of seeing right there is, the attacker is that low privileged user, but the attacker could specify an alternate subject alternative name. And in this case, it's the IT administrator down there at the bottom.
And we'll show a demo of that here in a second. So there's 8 escalation scenarios we covered. We're not going to go into depth on all of them. We're going to hit one of the more interesting ones in depth here in a second. But the first one, we actually broke these out. We numbered them. We numbered all the attacks because there were so many of them from a tradecraft standpoint, and we actually linked these to all the prevention and detection stuff. But the first one that we're going to demo, you have to have those general requirements, an EKU that allows authentication, like Lee mentioned, and the specific flag called enrollee supplies subject. This allows you to specify an alternative SAN, or a subject alternative name. And we'll demo that one here in a second. Escalation 2, general requirements, then the any purpose or no EKU for sub CA. While this doesn't allow immediate domain compromise as far as we know, you can create new certificates with any EKU and arbitrary certificate values, so this can potentially have implications for things like SAML, ADFS, IPsec, things like that. This is an open area of research that we're continuing to look into. Escalation 3, this one's definitely more complicated, but you need the general requirements and no enrollment agent restrictions, and you have to have the certificate request agent EKU, and basically this means that you can use this cert to request another cert on behalf of somebody else. So there's things called these specific rights that need to apply to the secondary template. This is really complicated. We break all this out in the white paper and blog post to a certain degree. But these situations are abusable even if they sound complex. So the first demo, we're going to show Certify, finding vulnerable certificate templates, which is find/vulnerable. We see, okay, we have the enrollee supply subject. There's no issuance requirements, those protections. We can authenticate to Active Directory with client auth, and any user can enroll the enrollment rights. So we're going to enroll in this template and supply an alternative name of administrator, even though we're running as low priv. It's going to go through, it's going to issue the cert to us. We're going to get this PEM blob with that alt name that we requested. So we're going to take this private key and certificate and transform it to a PFX, which is the format needed by Rubius. We can do this with OpenSSL. We do password protect the resulting cert because we don't just want to leave it around for anyone to use. Here we're using the super secure password of password. I'm showing here that I cannot access the domain controller's file system. I'm going to use the cert that can auth as administrator to get a TGT. I'm going to PTT it to apply it to my current session. It's imported. PK init, let me authenticate as administrator who is a DA. And then I can access the file system. Great. So that's a common scenario that we have seen in the real world.
Yes, we've exploited this on several occasions now.
So a few more of the escalation scenarios. Escalation 4 is vulnerable certificate template access control. So if you have edit rights over a template, you can edit those vulnerable settings and basically fixate some of the additional escalation 1 through 3. Escalation 5 is vulnerable PKI object access control. So like other objects in Active Directory that affect PKI, the different containers and like all the different little weird inner workings and stuff like that.
NT auth certificates object. If you can edit that, then
you can add whatever cert you want. You can add a rogue certificate. Escalation 6 is interesting. There's a flag that can be set in a CA called edit if attribute subject alternative name. This allows certificate signing requests for any template to specify a subject alternative name. So if this flag is set on a CA, then any template that allows domain authentication that doesn't have manager approval or issuance requirements, you can abuse.
And this is a registry setting that we've seen a lot of vendor documentation recommend enabling it in order for the product to work.
It's like an it just works type thing. But it's extremely, and Microsoft says this is dangerous. This isn't like brand new information. And 7 is vulnerable CA access control. So the certificate authority itself has access control. Specifically, the managed CA permission can be used to like fixate or like flip that registry bit for escalation 6. Now the really interesting one.
Yeah, so escalation 8 is NTLM Relay to the ADCS HTTP enrollment endpoints. So when you install Active Directory certificate services, there are some optional roles that you can enable that allow you to request a certificate using web-based technology. So by default, the only protocols that are supported are DCOM and RPC. But you can add these extra server roles and you can use HTTP in order to request certificates. The interesting thing here is all of those HTTP endpoints are vulnerable to NTLM Relay. So that means, for us as attackers, that's great because we can impersonate people while accessing them. The implication here is that if there is a user enrollable template in ADCS. So basically, if there's a template that allows me to enroll and obtain a certificate that allows for domain authentication, then I can, obtain a certificate as the victim user, and it extends my NTLM Relay window. So one of the problems, or one of the, I'd say, restrictions with NTLM Relay is they're somewhat short-lived. And so this allows me to kind of expand the window of impersonation. So I can immediately relay that to ADCS, obtain a certificate as the victim user, and now I can log on as that user for up to a year using that certificate. So that's one really cool, awesome benefit of abusing this. An additional one is we can combine this with the printer bug to impersonate any computer in the network that has spooler enabled. So what is the printer bug? The printer bug is a little feature I found a few years back. And what it does is it allows me to cause any machine to authenticate to me if spooler is running on that machine. So I can basically say, hey, hey, server over there, please authenticate to me. And this is great for NTLM Relay scenarios because I can say, hey, server, please authenticate to me. And then when it does that, I can use NTLM Relay to pass it on and impersonate that user to different services. So in this case, I can relay it to the HTTP endpoints and then impersonate that computer.
And we'll show a demo of it here.
Yes. So here, I'm just showing that I'm an attacker. I'm a low-prived attacker. I have a Windows and a Linux machine. So my first step is I'm going to create a certificate request. I'm doing this in the very manual way, so using OpenSSL, creating the CSR. And now I'm going to kind of prep this CSR for the attack. I'm going to URI encode it because we're interacting with the HTTP endpoints. So I'm going to URI encode that certificate request. And now I'm going to prepare the actual curl command that I'm going to use to request a certificate. And so that's the command I'm actually going to run. And now I'm going to get that command ready to run, but not execute it yet. First, I'm going to start up NTLM Relay, the NTLM Relay X, and in its SOX mode. And so that's going to start up right now. And now I'm going to coerce a domain controller to authenticate to my attacker machine here where I have NTLM Relay running. So I'm going to trigger that. Now that runs. Now I'm going to issue my request, and it's going to use the relay to request a certificate as that domain controller. So we got one. We got an ID there. So now we need to download that certificate that's associated with that ID. So we're going to trigger the NTLM relay again here so that we can authenticate and download the certificate. So that's what we're doing. We're going to coerce the authentication. Now we are downloading it, and we have downloaded it to a file, a .ser file there. We can see that it is on disk now. So now we are going to convert that to a form that we can actually use. So again, we're going to use OpenSSL and convert that and the private key to a PFX so that we can use it with Rubius. So we're going to add a password to it. The password here is ASDF, super secure. So now we have a .pfx file. Now we're going to transfer that to the compromised Windows machine where we have where we can actually use it. So I'm going to go ahead and copy it and then authenticate using it. So first step, copy it from our attacker machine to locally. And now we're going to use Rubius to request a TGT and a service ticket for LDAP. So Rubius gets a TGT. Now we're getting the service ticket. Now we're going to list the tickets, and we can see that we authenticated as that corp DC, the domain controller, and now we have a service ticket to the other domain controller. And so now we can do things like DC sync. And using Mimikatz, we were able to authenticate successfully, and you can see we were able to dump the curb TGT account. So we ended up reporting this to Microsoft because we feel like this is a default configuration and we feel like it should be fixed. But ultimately they said, it's not a valid finding. So, great for us.
Yep. So last little bit, last few minutes, some domain persistence with golden certificates.
So basically, all CAs, they have a private key on them, and this private key is used to sign certificates. And so the basic idea behind this is, if we can obtain that certificate, then we can forge our own certificates. And so if that private key isn't protected by a TPM or an HSM, then if it's not, then it's going to be protected by DPAPI, which means we can extract it. And so if we can extract it and that certificate is in the NT auth certificates object, then that means we can forge new certificates that are valid for domain authentication. So we can create new certificates for any user that we can then use to auth the AD. Something here too is these certificates can't be revoked. They weren't legitimately issued by the CA, so they aren't actually logged in the CA's certificate database. So you can't actually go and revoke them there, because that's in order to revoke it, it has to be in the database. And so and these will last as long as the CA certificate is valid, which by default is 5 years.
5 years, yeah. So obligatory meme.
Yes.
To channel Benjamin Delpy. One last little thing to mix in here, and we'll show a demo. But the MS-PKCA, so the PKInit Microsoft documentation, for backwards compatibility reasons, a legitimate certificate can be used to retrieve an associated user or computer's NTLM hash. So you imagine if you're authenticating with the cert, but some old device doesn't support this type of stuff, they had to have a backwards compatible way that you could then get that NTLM hash. So this is part of the protocol. It's first publicly or offensively detailed by Benjamin Delpy, and is recently integrated into Rubius by Ethical Chaos and Exploit PH. So Charlie and Sari. And if we combine this with golden certificates, we have an alternative way to obtain NTLM credentials for any active user or computer, meaning this is kind of like an alternative to DC Sync, even though it operates very differently. I'll show a full run through of this. So we're running code on the CA server, and we're going to steal the CA's private key.
Using Sharp DPAPI.
Using Sharp DPAPI. So we see here, we see the extracted cert on the left. I'm going through and you see the thumbprints match. So this is the CA's private key. You can see the issuer and the subject are the same. So this is, that's the CA's private key. So then we're going to use a tool called Forge Cert, which we're releasing with that private key, to forge a certificate for the administrator at the shire.local. So we see that thumbprint begins with E46. We forge this new cert. Now we're running as that low priv user. We can access the DC's file system, but we're going to use that forged certificate with the new Rubius 2.0 code base to get a TGT. Also, with the get credentials, we can get the administrator's NTLM using some user-to-user stuff. Now we have access to the file system on the DC. Now, on the DC side, we see that no certificate was issued, so there's nothing, we can't revoke it because there's nothing issued there. And the only event logs from the Kerberos side is we see that certificate legitimately was used to authenticate as administrator with that same thumbprint. So we think that's pretty cool.
Very awesome for domain persistence and credential theft.
Yeah. So as a quick summary, Active Directory Certificate Services has a lot of abuse potential. There's tradecraft from stealing certificates, doing active enrollments, all these domain escalation scenarios, domain persistence. There's a huge amount of tradecraft here. The ones we tend to focus on that we think are really interesting are especially that active kind of enrollment for LSAS list credential theft, but also the domain escalation stuff. Just so many different things. We have a 140-page white paper that has complete details about this. It includes extensive defensive information and additional architectural considerations. This is a kind of a short and sweet presentation to hit the main points. There's so much information here. The bit.ly link has a link to the white paper. It's also on the SpecDrops website.
We'll also be releasing the tools that we've talked about here, so Certify and Forge Cert. They're going to be live in our Ghost Pack GitHub repo, along with a defensive tool that we've previously released called PSPKI Audit. And so we'd love for feedback on any of these tools, and looking forward to other people using them.
Yep. Just quick acknowledgments. There's a lot of previous work that was done in this area. We detail all of it in the white paper as well as the blog post. Also, shout out to Sari for the PKNet related Rubius editions. And special thanks to Mark Gamache for collaborating with us on parts of this work. He's really awesome to work with. So, questions?